Landon, this is our Geometry Test 1 review. I'm having trouble getting these uploaded, so I'm going to try to do it in parts. So here, starting in problem 1, we have find the results if u is equal to x such that x is a digit. That just means u is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now looking at our problem, we have f, which has 0, 2, 5, and then 7, 9. And G, which has 1, 4, 8, and 7, 9. And then 3, 6 are in the U in the universal set outside of F and G. So F intersect G is 7, 9. That's what's shared between the two. F union G, when you put both of them together, is 0, 1, 2, 4, 5, 7, 8, 9, which is everything but 3 and 6. And F complement, or what's outside of F, is 1, 4, 8, 3, 6, or 1, 3, 4, 6, 8 in order. And then F intersect G complement. Well, first we find G complement, which is everything outside of G, which would be 0, 2, 3, 5, 6. And then we intersect that with 0, 2, 5, 7, 9, which is F, and we get 0, 2, 5. For problem 2, we look at the set J, which is the smallest one, 0, 3, 9, and then K, which includes J, which also has 6, 8, 1, 7, and then 2, 4, and 5 in the universal set outside the K. So J intersect K equals J is true because J is the smallest in what they have in common. But J intersect J union K is not equal to U, because J union K is K, and 2, 4, and 5 are outside of K, which make up the universal set. But J is a proper subset of U, because J is a part of the rectangle, and 6 is an element of K, because 6 is listed there in the K set. Now for problem 3, we have match each definition with its biggest problem. That it's not accurate, that it's not concise, meaning wordy, that it's not objective, that it's not reversible, or not understandable. So for A, we have an angle is the union of two distinct rays, and if we look at just two random separated rays like that, we can see that if we try to reverse this, the union of two rays as an angle doesn't work because it's missing the part of the definition which gave them a common endpoint. So this is definitely not reversible. Now radius is a chord containing the center of the circle. A chord goes all the way from side to side of a circle, but a radius starts at the center and goes to the side, so a chord is not a radius, and that makes this definition not accurate. Now for C, space is the set of all points, lines, and planes is too wordy because our definition when we did that was space is the set of all points, and that's all I need. So this would be not concise. Now for 4, list the 3 undefined terms in geometry, which are point, line, and plane. And for 5, name the characteristics of an ideal postulate system. And we said that we need it to be consistent, so that's required. That means that it doesn't contradict itself. We want it to be independent, which is the few postulates as possible. And to be complete would be impossible because there was a theorem in 1931 which stated that there was an impossibility of a postulate system being complete. On problem 6, we want to complete the following theorems, postulates, and definitions. If two blanks intersect, their intersection is only one line. So here we need planes, if two planes intersect. Now for B, a line and a blank not on that line are contained in only one plane. And that's the theorem, or postulate rather, a line and a point not on that line. Now for C, concurrent lines intersect in a single point. That was a definition. And for D, 3 non-collinear points lie in exactly one plane. That was a postulate. And if 2 points lie in a plane, then the blank containing them, these 2 points lie in the same plane. That was another postulate. So we needed a line there. Now for 7, we have a plane, P, up in the upper right corner, P. We have a line M that divides the upper half plane H1 from the lower half plane H2. And the upper half plane has points A and B in it, and the lower half plane has points C and F in it. Now to complete the blank on A, C, comma, would have to be F, is a subset of the lower half plane H2, because those are the 2 points there. Then H1 union H2 union M is the whole plane P, because we need the line separating the 2 half planes as well as the half planes to make the whole plane. And then H1 union M complement what's left of the plane after we include the upper half plane and the line separating is just the lower half plane, or H2. Now for 8, we have YZ, starting at Y going down towards Z, unioned with the half line XY, which goes at X, which is open, and then goes on down towards Z. Now since this is a union, we take in everything. So this would give us the answer of the half line XZ. And then for XZ intersect YZ, we have to take the lesser of the 2 for the intersection, so that would be just YZ. Now when we take the intersection of ray XZ with ray ZY coming back the opposite direction, we have just the line segment XZ. So now for 9, we want to say what kind of a polygon it is and whether it's convex or concave. So for part A, we have 1, 2, 3, 4, 5, 6 sides, which makes it a hexagon, and it is convex. For part B, we have a polygon, which is really, it's not a polygon really, because it's not simple. The problem is that it crosses itself, making it not simple. For part C, we have a decagon, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides we can count. A decagon, and it does cave in on itself, so it's concave.